Okay, so we have displacement versus distance, average speed versus average velocity. We're going to use d as our unit or as our variable for distance. T is going to be for time. And we're going to use S for average speed. So average speed is total distance divided by total time. Even the time that you are not moving, it counts. Okay, distance is always a positive number, even if you turn around. That doesn't matter. Whereas, all right, average velocity is your displacement, all right, divided by the time. Now displacement, this little symbol here, all right, don't freak out about it. That little triangle pretty much just represents final minus initial. So like temperature, final temperature minus initial temperature is the change in temperature. So X is our position. So it's final position minus initial position. That is our displacement. And all right, basically how far are you from your starting position? And that can be a negative number. So here we have a position time graph. Position is on the y-axis and time is on the x. So you have to really pay attention to the y-axis here because that's very important as to getting our pieces of information. So where do we start? At time 0, what position are we at? Where's my little, do I have a little highlighter? Yeah, so at 0, we are here at 2. Okay, so that's where we're starting. That's good to know. Now, we go from 2 up to what? Right here. So at 4 seconds, what position am I at? 4, right? So what you do is you go to 4, right, or you go to that position right there, and then you go over to the y-axis, and you are, boom, at 4. So from 0 to 4 seconds, I moved a total of 2 meters, right? I went from 2 meters to 4 meters. So what do you think, guys, is going on from the 4 to 12 second range? Walking straight, nothing. What? So again, position is on the y-axis. So right now, right here at 4 seconds, you're at position of 4 meters. Does your position change at all until you get to here, the 12-second mark? No. So when you have a flat horizontal line on a position time graph, that means you're not moving. Okay. Now, at 12 seconds, from 12 seconds to 16, you change your position. So you're at 4, and we go up to how much? Here and go across to 8. Okay, so in this little segment here, we went 4 meters. In this segment, we went how far? 2. So how much did we travel total? Yeah, all right. We traveled a total of 6 meters. So you guys will fill that in. So average speed is our total distance traveled divided by the total time. Okay, so here we have a total distance of 6 meters. And how long did we move for? How long was this total trip?
16 seconds.
Good, 16 seconds. So when we divide out, we're going to get, let's see, what do we got? 6 divided by 16, and we're going to get a value of 0.375. Now, what will my unit be? So again, from the video from yesterday, it's the distance unit divided by our time unit. So you could have like kilometers per second, you could have kilometers per hour. So here we used a distance of meters, and the unit for time was seconds. So we're going to have meters / seconds, ms. Now that's going to be the most common one we deal with in this course. All right, well, what about the displacement? So displacement, they only care about delta x, change in position. So what we're going to do is we're going to go final position minus initial position. Okay. So what was my final position of this trip? So at 16 seconds, where am I? I'm at 8. Minus Where was my initial position? At 2. So we're going to say 8 minus 2, and that is going to equal 6 meters. Okay. Average velocity. Now, here we have average velocity is delta x divided by t. So we just figured out our displacement is delta x, 6 meters, and our average velocity is going to be this 6 meters divided by the 16 seconds. So we're going to get the same answer, 0.375 meters per second. So remember, guys, that velocity does worry or have a direction. All right, it's a vector quantity, so is displacement. So what you could do here is you could say, okay, positive 6. So if you really wanted to, you could say positive 6 meters, and then you could say that this guy is a positive 0.375 meters per second. Both of those work. All right, both of those are acceptable. All right, because it will be understood that for the most part, unless you are specifically told otherwise, right, this 0.375 meters per second is the same as this. But 0.375 and negative 0.375 are very different because now the negative comes into play indicating our direction. Okay, so we got boom, done. And boom, done. All right, let's go to the next position time graph. All right, so let's figure this out. Where are we starting at? 5. Okay. So are we moving during from 0 to 2 seconds? No, because our position doesn't change. At 2 seconds to 6 seconds, we changed our position, right? We were at 5, and now we're at, if I go here and then go to the y-axis, I'm at 1. So how far is that? 5 to 1 is how far? Okay, and then we don't move again. So with the total distance traveled, guys, is going to be 4 meters. Okay, well, what about average speed? Again, average speed is the total distance divided by total time. Well, we only moved a total of 4 meters, so 4 meters divided by 8 seconds this time. That is going to be 0.5 meters per second. Okay. So now we got to find displacement, delta x. So final position minus initial position. So where at 8 seconds, that's the final part of the trip. Where are we? We're at 1. Okay. So that is VF, or X sub F. So we're going to start at 1. Now we hit minus. Okay, well, where were we at originally? At 0 seconds, we were at 5. So that's initial position. So we have 1 minus 5. And that is going to equal, good, very good, negative 4 meters. So now my average velocity, guys, is
-4.
Well, not quite. Remember, it's not, well, you're going to do the similar equation because, again, it's our either distance or position over time, but it's not just -4. So displacement divided by total time is our velocity. So we're going to do displacement, which is this -4, and how long we're moving for? 8. So -4 divided by 8 is going to equal negative 0.5 meters per second. So in a problem, if you forgot to put the negative for a velocity and that was actually needed, but you got 0.5, you would technically be wrong. Okay? So definitely keep that in mind.
We don't have that.
What, this?
Or which side of it?
I added it onto mine. If you wanted to do that, you could click like highlight that and then plop it down here. You could do that if you wanted to. Delta X is final position minus initial position. Okay. So guys, now we're going to use this number line here. So first one, start at 0 meters, walk to the 10-meter position, and then stop. Now notice here, it says here, assume that all trips take 10 seconds. Now, I don't think you guys have this on yours. These little pieces of information. You have distance traveled m, average speed meters per second, displacement m, average velocity meters per second.
We have all trips.
And you have all trips are worth 10 seconds. So these are the variables. These are what the letters are for these variables. All right, distance is d, so average speed is distance divided by time, and then displacement is final minus initial, and velocity is displacement over time. So if you wanted to add those in, you could. All right, so but let's walk through the first one together. So you're starting here at 0. And then it says you walk to this 10-meter mark. Oh boy. Excuse me. There we go. And stop. So how far did you travel actually? Yeah, 10 meters. It's not even a trick question. Simple. Okay. So the average speed is distance divided by time. So we traveled the d right here, distance of 10 meters in how many seconds? In 10 seconds, because all trips take 10 seconds. So 10 divided by 10, very simple, is just 1 meters per second as our unit. Okay, what about displacement? So it said we go all the way to the 10-meter position and stop. So my final position is 10, correct? Okay, so 10 minus, what was my initial position? 0. So 10 minus 0 equals 10. Now you can say positive 10 if you want. Up to you guys. But 10 meters. So now our displacement is 10. Again, our total time is 10. So this, guys, here is going to be the same thing. You can write positive 1 meters per second or 1 meters per second. So right here, you can have the same exact speed and average velocity. You can have the same average speed and average velocity. Okay. Well, now here, they said, okay, now we're going to go start at 0 and walk to the negative 10. Okay. How far did you move? 10 meters. That would be it for displacement. So distance does not, that's a good question. Distance doesn't care about direction. So you can't ever have a negative distance. So we have, all right, this full 10 meters. So again, distance divided by time is going to give us an average speed of 1 meters per second. But now displacement. We finished here at negative 10. So we have a negative 10 minus, what was our initial position? 0. So negative 10 minus 0 is going to equal a negative 10 meters. So what does that mean? It's you're behind. All right. This is the negative here is essentially just telling us a direction. So if we wanted to say right was positive and left was negative, this would be telling us, okay, bless you. Now we're 10 meters to the left. Okay, bet. So in velocity, what we're going to do is negative 10 divided by 10 and get a negative 1 meters per second. So velocity, you guys, if it's supposed to be negative, you have to make sure you have the negative sign there. Okay. So, let's try looking at this guy. All right. So now we're going to start here at negative 2 meters. We're going to walk to 0 meters, and then what? it says back to -2 and stop. So we went from here to here and back. So we went, right? We went 1, 2, and then 3, 4. So we moved the total distance of 4 meters. Total distance divided by total time. So 4 divided by this 10 seconds is going to equal 0.4 meters per second. Okay, displacement. What was our final position? Okay, so we're going to have a -2. So I'm just going to put this in parentheses so we can see this. All right, so -2 minus, okay, what was our initial position? -2. So if you bunch this into your calculator, you're going to get an answer of 0. Now, if you ever have that, you don't need to worry about a direction because, all right, you're back to your original position. So, okay, well, what is my average velocity of that entire trip? Well, it's going to wind up being 0 divided by 10, which just equals 0 meters per second. So, you could have the same trip. You could have, again, you can have a difference in average speed. You can have a difference in average velocity. Can you ever have something where you have an average, if you actually move, can you actually wind up with an average velocity of 0? Yeah, you can. And how? Well, you have to basically come back to where you started from. Okay, 4, you started -3. Okay, let's take a look actually first though at number 5. I want to look at 5 instead. You guys should going to do 4 on your own and 6 on your own, but let's look at 5. So we start at 4 meters and walk to the -1 meters, then back to 5 meters and stop. So we're here at 4. We go to -1. So we're going to go, so from 4, this will be 1, 2, 3, 4, 5. And then we come back. 6, 7, 8, 9, 10, 11, because they told us to stop at 5. Okay. So we moved the total distance of 11 meters. So distance divided by the time is going to equal 1.1 meters per second. Okay, well, what about position? Or what is our displacement? Okay, well, what was our final position? 5 meters. What was our initial position? 4. So we have 5 minus 4, and that is going to equal, right, 1, a positive 1. So velocity is displacement divided by time. So we have a 0.1 meters per second. So again, same trip. You have a difference in distance and displacement. Therefore, you're going to have a difference in average speed and average velocity. So you guys are going to do 4 and 6, okay, on your own. Do that now.